Well, hello everyone, and welcome to today's webinar of an assessment of lightweight quad-pane windows. Before we get started, I'm going to review just a few webinar logistics. Today's webinar is based on an evaluation by the National Renewable Energy Laboratory, and you can find the full report as well as summary documents on gsa.gov. And we'll also be posting links to these documents in the Zoom chat window. Today's webinar, you'll be all in listen-only mode, and you can submit questions by using the Q&A button on the bottom of your screen. And you don't need to wait until the end of our presentations to submit questions. In fact, we encourage you to submit questions well in advance of the Q&A session. Today's webinar is being recorded and will be shared, and you can find presentation slides and recordings for all webinars on our webinar page at gsa.gov. And you can also access all of our webinar recordings from past webinars on our YouTube channel. And we're pasting links now into the chat for both our webinar page and for the YouTube channel. And with that, I'd like to turn it over to Kevin Powell, the Director of the Center for Emerging Building Technologies.
Thank you, Andrea, and it's great to see so many of you here on this webinar. Just a few notes about what we're going to be doing on this webinar. First, I'm just going to offer some overarching comments that'll put this technology in context. Then we'll hear from our researcher, Kasal Kiya-Riyamwatana, who led our evaluation, who will really describe what kind of performance we have seen, and I think it's something that you'll find quite exciting. We'll follow that with some on-the-ground feedback from Tyler Cooper, who's our Supervisory Energy Project Manager in Region 8 and led the field evaluation of this technology from GSA's end. And then really the most important part of this webinar is you, and it's the Q&A, the questions that you put forwards, and that we'll be able to provide hopefully some insightful answers to. Next slide. So I have to say that we've had 80 technologies that have been selected for evaluation and validation through our Green Proving Ground program. And none are more exciting to me personally than this one. And that's really because really the windows remain really the biggest obstacle to making our buildings more energy efficient, and really are the key to all of our net zero goals. Up till now, windows really have not had anything like the performance of a wall. So the most efficient building would be a building with no windows. Who wants to work in that kind of environment? Back 30 years ago, when double glazing was state of the art, LB&L came up, another national lab, with an idea of how to make a highly insulating window. They manufactured it, they proved out that you could do it. The problem was you couldn't cost effectively make that sort of window. And so what's super exciting about this particular technology is that for the first time, what we actually have is a window that has the kind of essentially has the insulating performance of a wall, and yet of course is completely transparent. You can look through it, and it is really not that much more expensive than a double pane window. Same form factor, similar kind of weight. And we think, again, it'll really be a transformational technology. So we're excited to share that with you. Next slide. The research that underlies this is available on our website at gsa.gov/GPG. You can find the full evaluation, as well as a summary document, as well as a one-page infographic that can help you communicate these results to others and communicate them to yourselves. I should note that this particular webinar is focused on this lightweight quad-pane window. This is a window that is appropriate to new construction and major renovation, where you're replacing, either replacing or installing windows, to fit in a frame. There is the same company has similar, essentially the same core technology in a different form factor as a window insert. That's a lightweight, easy to install and easy to remove panel that can fit in front of your existing window. We just released results on that, and we're going to have a webinar on that technology, separate webinar in March. And with that, I'm going to turn this over to Kasal.
Thank you very much, Kevin. Good morning and good afternoon to wherever you are. My name is Kosol Kitruangwattana. I'm a researcher at the National Renewable Energy Laboratory. Been with NREL for over 12 years, and then before that with the consulting firm for another 11 years, so about 25 years of experience. Today I'm going to be presenting our research work and that we conducted this study over the last year and a half, almost 2 years with the COVID. And again, this is the highlight of this study. It's a lot of detail of like the findings and then the criteria of this study, a lot more. So I encouraged anybody who like to learn more in detail to check out the full report for more detail. Next slide, please. Again, what's make it the attractive choice? What's a lightweight, quad-pane windows? The quad-pane, as a name, is basically comprises with 4 panes of the insulated material, and then in the fiberglass frame, and then with the inert gas field, usually either argon or krypton. In this case, we using krypton gas field. And the thing that make it the magic of the lightweight is the inner panes inside. It's going to be either the thin glass technology, then or the suspended film, and then with the spacer, insulated spacer that's in between. Approximately thermal performance, it's R8 full frame. So when we compare with the Energy Star windows, which only about R3, so it's this significant improve on the energy efficient thermal performance. The installation, because of this lightweight material, and then it's the form factor, the profiles basically can be fit, and it's very similar to a double pane windows. And when compared with the weight, it's basically 50% lighter than the standard triple pane. Next slide, please. So what makes it so appealing, the lightweight, high efficient, and versatile applications, of this technology, because of the, for example, with the thin glass, the thin glass has the price has dropped significantly. These thin glass technologies been used with the smartphones and the flat screens TV, and it's very popular, make it the price come down significantly year by year. The krypton gas, like I mentioned, that's a lot of like insulating windows. They often fill with the inert gas, either argon or krypton. Krypton used to be very expensive, but with the price, come down significantly, and krypton is the also one of the best choice for the gas field. With the 6 times denser than argon, approximately 12 times denser than air. So the in terms of like insulating property, it's significant. The thin glass technologies, can be used without frame, with frame or without frame. So it can be used as the curtain wall applications. And also the units with the thin glass can be made for blast resistant as well. So, next slide, please. So this is like kind of a high level, kind of show you real quick the comparisons of these thermal performance. You guys pretty familiar with these terms, you know, U factor or the R values. The U factor, basically the lower is the better in terms of thermal performance, like, you know, invertedly, same thing with the R values, that the higher number is the better insulating property. So when you're looking at this with the high performance double pane, the R value approximately 3.1. The high performance double pane, I want to mention though that this is a minimally requirements for the new GSA for new construction. So this is the minimum requirements. So approximately R.1, 3.1, and this is an Energy Star. So compared to, like, you know, triple pane 6.7, and then the Quad-Pane at 8.3. From the manufacturers, as they mentioned, that's the incremental cost between the triple pane and the Quad-Pane is approximately 5 to 7%. So make it a big significant benefits in terms of, like, you know, improve performance at the small incremental cost. So next slide, please. So when we comparing, like, you know, these two technology, the thin glass and suspended films, they're both providing superior performance. But just want to showing you that with the cost trend, with the thin glass, it's slightly cheaper, but however, it's slightly heavier. Anyway, when we talk about heavier, again, this is lightweight, super lightweight for both technology. And another factor about it is the condensation resistance. Condensation, I'm going to go in more detail. You know, in general, these both windows providing a superior condensation resistance that could happen in the climate zone, cold climate zone. And both can, the solar heat gain coefficient, both can be customized. And one thing about the suspended film units can be made and meet the tempered glass requirements. Next slide, please. So with our research for the demonstration and technology validation, we conducted at Denver Federal Center, Building 41 in Denver, Colorado. People who might familiar with this building is basically it's a large office building, and we conducted in one of a wing in the west side. So next slide, please. So we have installed total of 10 windows, you know, 5 from the thin glass unit and 5 for the suspended films. We install monitoring equipments, sensors to measure glass, frames, surface temperatures, space conditions, outdoor conditions. And we use information of the window from the manufacturer, build the DOE, the model in the DOE Windows and term software. That's this is the 2 key software that's widely used in the industry and also in the researcher, and even the NFRC also use these 2 when they calculate and estimate the thermal performance. And then we use the results that we will calibrate with the measured data that we have. Once, like, we calculate these thermal performance indices, we use these performance numbers and then model the whole building's energy simulations, and for calculated HVAC capacity reductions, energy savings, and the economics of the projects. So on the right hand side, it's a lot of like, pretty busy, but I want to, showing that a lot of data and we have to doing the monitoring the long period of time. But, with the only a certain data that will be used as like, to meet the criteria when they calculate this thermal performance. Just want to show you. So next slide, please. So this is like a high level, like, modeling results. The key simulated results, the U factor, the solar heat gain coefficient, visible light transmitting condensation resistance. Hopefully, like, some of you pretty familiar with this term, but let me know if you wanna me to kind of go over during Q&A for this information. As you can see that, these both windows providing a great low U factor or U value, and then as well as like, all these number match pretty well, very well. I don't want to say pretty well, it's very well between the modeling results and also with the measured data. On the right hand side, this is showing the therm modeling, showing the two-dimensional heat transfer, temperature profiles that's happening within the windows, and then a pretty small number showing that's, some small font showing the number of the predicting temperatures, at the surface temperatures with inside and outside very precisely. So we feel very confident on the results of this model. Next slide, please. So this is another study that we do. Thermal comfort is it's a big thing when we're talking about besides like energy savings, right? So because it's thermal comforts mean a lot of like many things on the saving, productivities, and etc. So you can see from the right-hand side, this is the plot. This is a measured data that we have with the actual data during very, very cold days in the winter. With the outdoor temperatures at approximately 22 degrees Fahrenheit. You can see with the set point inside approximately 69 to 70 degrees. And the center of glass, the temperatures showing it's holding the temperatures really well, between 65 to 66 degrees. When we compare to like a lot of the time, even you at your office or like, at your house, you touch on your window surface, you can feel the cold surface of those windows. So these windows like holding the temperatures really, really well. What does mean on like, warmer window surface? Technically it's reducing a lot of like convective and radiative heat transfer effect. When we talk about this term, when that's mean like when you're sitting into like next to the window, you feel drafty window. That's what they're talking about, right? So with the warmer surface, you reduce a lot of drafty feeling sit next to it. And with the results, like, we conducted like thermal analysis, like follow the ASHRAE 52, a lot of detail in the full report. So I encourage people who are interested in to look into more, to look into the full report. And the majority of the conditions that were within the comfort boundaries during our study. So next slide, please. So this is an additional benefits of this type of technologies, besides like the energy savings that you would get, also with the new construction, with the better building envelope, that means you're reducing your thermal loads, both on heating and cooling. So this is another additional for the new construction. When you sizing your HVAC, means you can downsize your HVAC capacity. And also with the major renovation, if your major renovation happening on the HVAC and then the building envelope at the same time, you can take out the benefits of like downsizing your HVACs as well. So from our study, it's showing that the HVAC capacity reductions, we got approximately 8% for the heating and up to 18% for the cooling. And with the estimated savings of the projects is approximately $120,000 savings, or about $6,000, annualized over 20 years. So next slide, please. So condensation, again, condensations, this is a rating that's, in the, if you're looking at the NFRC level, you will see this type of rating. It not necessarily required, but it's such a good information when you're selecting the windows, particularly with in the cold climate. In the industry, it's recommended that the condensation resistant rating, ranging from 0 to 100. The higher is better. They recommend it's a minimum of 50 for the cold climates. And from our studies, it's showing that this window have the condensation resistant rating at between 65 and 67. One interesting thing about it is like we are even expecting a higher number, particularly with the thin glass unit. With the time constraint during the study, somehow the unit was built with the steel spacer, and instead of a warm edge spacer that will improve overall performance and as well as the condensation resistance. And the manufacturer estimate that it could get up to CR of 80 in that study. Next slide, please. So when we talk about the energy savings, we conducted these simulations studies and using the DOE commercial reference building for large office, all the building envelope, and then all the anything that climate sensitive was, get into this model that we take into account. And then we run the analysis for these 10 climate zones, from the hot climate, hot and humid climate to like a pretty cold climate. And the results showing significantly improvements, significantly higher savings than a typical double pane, so high efficient double pane windows. We also model this with the GSA utility rates, three different three GSA utility rates, at the low, mid-level, and then the high level. And this result showing for the mid-level. But again, all the results is more detailed, can be found in the report. You can see we're looking at the heating savings, cooling savings, fan saving combined. We call it HVAC, energy savings. Absolutely, for the heating saving, we see more energy savings, for the cold climates. Vice versa with the cold cooling, we see more in the warmer climate. Overall, we seeing the total percentage of energy savings average about 24%, and the payback within 2 years. And again, this is like comparing with the high efficient double pane windows, and we're using the incremental cost for this analysis. This number meant to be like providing your results. I know that a lot of us, sometimes we use it as a rule of thumb. So this is meant to be showing for your screening. It's very good, still very, very useful for your screening. But when we're looking at the actual performance energy savings, I encourage the energy modeling for particular buildings that you are working on is necessary. That's why it's because it's so unique to the building, but this is meant to be a screening, and you can see that it's such a attractive choices for the energy efficiency improvements. Next slide, please. So in summary, again, this is like the number. It's for our climate zone, for our utility rates. You know, it's ranging the savings we see is between 19 to 34%, you know, compared to the high performance double pane windows. And the side benefits can reduce your HVAC capacity requirements for the buildings, you know, downsizing the units. And then, you know, with the benefits of the slim profiles, you know, it's the same, very similar thickness, you know, comparable weight to the double pane windows. And, you know, with this superior thermal performance, it's improved the occupants' comfort significantly. And then like with the slightly incremental cost, you know, in between, we talk about like $2.50 to $4.50 when compared with the double pane windows. And the payback, it's really, really good, 1 to 6 years, and making this technology as one of the appealing options for your projects, for your improvements, the projects. Next slide, please. Okay, and then I'm gonna pass the presentation to Tyler Cooper from the GSA. Thank you.
Thanks, Gasol. And with that, we'll go to the next slide. So, yeah, one of the key highlights from this, wanted to highlight is the fact that these quad pane windows are an identical, pretty much identical installation and replacement compared to a typical double pane window. So going through the installation process, you'd go through the same measurements, same removal of the existing windows, as well as the same installation of the new windows. With that said, they are the same weight. And then you look at a standard triple pane window, 50% lighter than that, with the window that is made of standard glass. You look at potential use cases for these, we're pretty much going to see it across the board. It's got fixed installations, ribbon strip, large punched openings, as well as window wall installations. The primary application that we would see these for would be obviously new construction, retrofit, but within that, we'd still apply them. They've got use cases for residential scenarios, commercial buildings, as well as industrial and high performance buildings too. Next slide. So these windows were originally installed in building 41 in the fall of 2019. So we had about roughly 4 months of actual occupant feedback prior to COVID hitting and all of our workers working from home at that point. So that kind of impacted the study results a little bit from the occupant feedback side. With that said, we did get some good results from the winter months, and 4 out of 5 occupants recommended the window retrofit going to these quad pane windows. The previous windows we had installed in building 41 were a mix of electrochromic and thermochromic windows in this area. So within that, due to the nature of these, we've got a steady performance year round with those, much more visually appealing compared to a thermochromic or an electrochromic window that is modulating and maintain those characteristics. Within that, one of the big things that we've seen, regardless of installation, is that if you've got direct sun glaring down on the windows, you are still going to have some occupant discomfort if there aren't blinds in place, but we'll still maintain that thermal performance of the windows. So next slide. So best practices, as Gasol mentioned, one of the things we're trying to optimize for this is working through optimizing our building envelope. Within that, upgrading these, you're pretty much bringing the windows equivalent to the performance of the overall building envelope, which does allow us to go through and lower the capacity needed on our HVAC equipment for the buildings, which is one of the first steps in going towards our net zero energy goals. Within that, the window configuration, These are highly customizable windows based on the needs of your building and the climate zone you're in. We can optimize, as mentioned, optimize for the solar heat gain coefficient. If you are in a heating dominated climate, you're going to want a window with a higher solar heat gain coefficient compared to a cooling dominated climate where you'd want one with a lower solar heat gain coefficient. Block the heat gain more effectively and keep that cooling in your building. Along with that, we can also modify the visible light transmittance based on needs of the occupants, as well as a number of other characteristics. But within that, the overall goal is making sure we're getting the windows specified to get the highest performance in the building. Next slide. So within that, the overall deployment recommendation for these windows is new construction and end of life replacement. They're still they are a capital project in that sense, as most window projects are. Within that, though, they are supporting our net zero carbon emissions goals. We're not going to get to net zero emissions in our buildings without first improving the envelope and making sure that we have the building performing at the highest level. With the current pricing, the thin glass configuration is more cost effective. Saul mentioned that's about $2.50 more per square foot compared to the conventional double pane, high efficiency double pane windows. At the inverse of that is the suspended film version, which does offer more selection in the actual films you use, the low E coatings, and provides better UV protection when that's needed. As we mentioned previously, the film version is also lighter, about a pound per square foot lighter compared to thin glass. Then within that, mentioned these are end of life replacements. If we do have lower performing windows, be it double pane windows or single pane windows, which hopefully we're eliminating most of those out of our portfolio at this point. There's another couple options that we've considered. First being secondary window inserts. We've had great success with those, and we'll actually be talking about those at a future webinar in March. Those have a lower upfront initial cost. It makes those good based on if you aren't looking to replace the windows for another 10 to 20 years or so, kind of that intermediate stopgap solution, as well as going to and applying the low E film on the existing windows, both secondary options that you can consider rather than going to a full window replacement. And with that, next slide, and I think we'll take it back to Andrea to start our question and answer.
Great, thank you, Tyler. We do have a lot of questions. Thanks for all of those. I'm sure we're not going to get to all of them. We'll get to as many as we can, and we will be sending out an email afterwards with the top questions and any answers that we can't answer right now. We'll get back to you. So first question, how does the long-term durability compare to standard IGUs? I think either Kasal or Tyler, you can probably answer that.
Yeah, this window we expect to be similar in terms of durability and then longevity of the units. You know, the windows in general estimate to last at least 20 years. So we can expect like, you know, at least like 20 years, you know, in use. So.
Okay, great.
Tyler, you have anything? I'm sorry.
No, thanks, Kasal.
No, I concur with that, Kasal.
Okay, so how does view distortion on a quad pane window compare to that on a dual pane window?
That's an interesting question. Thank you. However, like, you know, when we're looking at visually, we didn't see anything. But again, like, you know, the with even though with the suspended film, that people might think that, wow, how can you, like, you know, making the films, like the company making the magic, you know, we didn't see any distortions. There might happening at the extreme angle. I would expect maybe a little, but as in terms of like, you know, we didn't notice any distortion.
Great. Thank you.
Yeah, from a visual inspection of that, you have to physically be within probably a foot of the window to even see the film or the suspended glass there. So that's if you're looking at it from a distance, they look identical to a standard double pane window installation.
Great.
That's a really good point. Yep.
Thank you. Can this technology be incorporated with bullet resistant glass?
that's, when we talk about blast resistance, it's definitely can be from, we talk about, that means like, I'm pretty sure, but we talk about super thick windows, laminated, whatever laminated they will put for that meet the bullet. That's information maybe have to work directly or consult it directly with the manufacturer, as far as like, with this a typical application that we are having. I would say that it might provide some blast resistance, but in terms of bullet resistant, I'm not sure yet, but we can, hope to find more information.
That's right. I guess you're right. That's blast resistance and then bullet resistance. We know that we can work on them with blast resistance, and I think we'll probably get back to you on the bullet resistance. Is there any concern about krypton leakage? Can you comment on the window construction or design to assure tightness and long-term integrity?
Yep. For this krypton or argon, in general, like a lot of people, this is maybe a bad press in the old days, that people think, oh, it's gonna leak, and then what's happening, and then like it's gonna leak. I mean, like, it's gonna leak eventually. But when we talk about it in the independent study, looking at the leakage is pretty minimal. We can estimate like approximately 1% per year. That means like, the window lasts about 20 years a minimum. You probably in the 20 years, you still holding at least 80%, approximately 80%. And then the manufacturers say like, at least 80%, about 80%, you still get a lot of benefit of this inert gas in between. So we look into it. I don't think it's not a big factor, with this. And then either, with the warranty and with everything, we feel pretty confident that, it's pretty minimal.
Great. Because the windows are lighter and thinner, are the standard Quad-Pane windows as hail resistant?
Hail resistant or not, it's like basically on the outer pane, and outer pane is a standard glass. So I would expect that, a similar hail resistant that you would expect with a standard double pane. Definitely a golf size of, golf ball size, probably not, but I think in a certain level.
Great. Could this technology be used to replace glass in existing casements?
Okay. When we talk about the existing casement, here's one thing. When we, because of this window, came with a very good frames, fiberglass frame that make it like, the frames heat loss is significant in general for the windows. When we talk about the center of glass of these windows, center of glass performance, we're looking at over R10. But once like, combined with everything, it's coming down to about R8, and means like, the framing, the edge heat loss is significant. So a better frame is better. So I would, in terms of like, can be fit into like existing, of course, because this can work even from the frameless, configuration. But I would recommend, if you would like to get the full performance, better performance, maybe framing, changing the whole casement is a better idea.
Great. Well, a couple of people commented on that the research was kind of limited. It didn't have research in the Northeast and other regions. I know, Kasal, there's other research in the report. Other cities are modeled, so there's more. We have more research. Is that correct?
Yeah, that's correct. And the thing is, like, we want to be also very consistent, with what a GSA in terms of the building stock. A lot of like the GSA building stock are within this climate zone. However, we have some expanding some resource, like, to cover our climate zone as well. But the result we're presenting specifically for GSA.
Great, thank you, Casal. Are these windows commercially available in large sizes like curtain walls? I think you mentioned that, or are they only for smaller residential windows?
This is like, first of all, this is the study we conducted is for commercial application. So number one is like this is a large commercial size, and my understanding the windows can making as a curtain wall. So yeah, the size can be very large windows.
Great. There's a comment that recently Krypton prices have increased dramatically. And so that I know that I'll answer this one because we've been talking to the manufacturer about this, that they're looking on certifying gas blends of argon and krypton together that should have similar performance.
Yeah, I was gonna add, I'm not so sure if it's about COVID or something. I don't know. Maybe with the labor shortage, inflation, you never know. But
okay. There are a couple questions about the costs and about that $35, $37 a square foot, and whether it's a complete window or just the thin glass layers.
This is a complete windows. However, like, not including in, I saw another question about install cost. So because of this study, we're doing as more like an incremental cost. So with the same profiles, similar windows, so we assume that the cost of the installation between the double pane and the Quad-Pane are the same as the wash. So this is like, just material cost for window.
Couple questions about whether the windows are commercially available now and the manufacturer.
Yep. Okay. So I'm not going to speak to on behalf of my manufacturer, and I know that they are pushing. They both a lot of manufacturers. Now you can see a lot of triple coming out to the market, and then the quad hasn't been in the commercial much, or you haven't seen much, but actually it's commercially available as far as I know. And again, this is for commercial application, and it's residential. A lot of the time you start seeing a lot more on the triple, but I'm sure that the company can make this unit for a high-end residential. I don't want to call it high-end. I don't know like in terms of like the residential sector. What's the price difference or thing like that. But I'm sure it is available.
Yes, I think that's right. They are available for both commercial and residential. And then the technology that we tested in this M&V was provided by Alpine High Performance Products. And so that was the particular version of the Quad-Pane that was evaluated.
Great, I'll interject too. Yeah. I think I saw another question kind of going as far as the scoping specification for the windows. And I think from like our perspective, essentially go through a prescriptive requirement, identify the performance characteristics you're looking for the windows, Quad-Pane windows, performance that you're looking to achieve with those, and put that in your specs for the project. And that would be the recommended route at this point in terms of getting to a high performance window installed as part of the project.
Great, thanks, Tyler. Can you tell us about any glare control that is included in the windows?
Okay, again, I don't want to give out like the research we are doing. There's a company, there's a manufacturer that's trying to integrating, like we talk about like the glare or like solar control, those type of you should estimate that the glare control like with other similar to other high performance windows. But we talk about like in terms of like in the glare control, shading control, those kind of things, automate. There's a research like it's happening right now. That's all I can say about it. Yeah.
Okay, great. So I think we answered some of the other cost questions. Can they be used in regions subject to earthquakes, tornado, or severe storms? Is there any reason that this would be different than another type of window?
Yeah, when we talk about the technology, people might scare about like the thin glass and then the suspended film. Again, this is like from the inner panes of the window. Outside is still using the standard glass thickness. So whatever is applied to that region of course, like, will meet that, they probably meet that kind of requirements. But in terms of like, this is like such a something like tornadoes and earthquakes. This is, this could be something that maybe have to discuss with the manufacturer in more detail.
Okay, great, thank you. Couple of technical questions. How do you measure surface temperatures when the pane is in sunlight? And I guess another question related is for what are the surfaces for which the temperature is being measured? The glass surfaces?
Yeah. As far as I can tell, that we not only just doing a single measurement, with the surface temperatures, and that's a very good question. This is, I'm sure that people who ask me, also a researcher. we did a lot of the surface temperature. I think a total sensors per windows is at least like 20 sensors, that we put into a single windows, and with center of glass near the edge, all kind of and it's a special sensor that we can answer you in the detail that what kind of sensor that we are used, so we'll not bore everyone. But yeah, there's a research level sensor.
Great, thank you. And how do you quantify the reduced convective and radiative heat transfer effects? Was the mean radiant temperature measured? So another kind of more technical.
Yes, yes. There is the tool from Lawrence Berkeley. That's the from CBE. I'm sorry. For that tool, there's a lot of like we conducted that study as well. There is a lot of information, a lot of model that we put it in there, come up with the radiant temperatures of that, and then when compared with the results. So I encourage to look in more detail in the full report, and then shoot me an email for additional information that you might have. But we did the analysis on that.
Okay, great. And are the windows made in the United States?
Yes.
Yes, they're made
local, actually.
Yes,
yeah.
Yes.
Yep.
Is the Quad-Pane available in a low iron pane configuration to improve visual transmittance? I'm not sure I understand that question, but maybe you do, Kasal.
Yeah, I'm not 100% sure if I understand either.
Okay. We'll just move on, and we can come back to you on that one. Okay, so there are a couple of questions, a number of questions on the window inserts as well. And that webinar, we're not going to really touch on answer those questions now, because we'll be hosting that webinar in March. And so that some of these questions we can answer at that time. I guess we've already answered the glare control. Have these windows been installed in any historic facilities? I don't know if we have the answer to that.
Okay, I think one thing that people who all knows that historic buildings, often there's some prevention of like any significant change of the appearance, of this exterior in particular. That's what the next technology that we're going to discuss in March. It's a very, very good application for these type of buildings. Okay,
great. Big glazing projects are significantly affected by the glazing product lead times as well as price. Do we know whether these can be manufactured at scale with the lead times that a conventional energy code baseline window are available?
This information, this is more like, manufacturing side, but so far that I have talked to these manufacturers, they seems to be in full speed. There are a lot of interest on their technologies. So I assume that, of course, this is not something that off the shelf. So you might have to providing some lead time in terms of get it, manufacturer, but it's not probably gonna be like available right away off the shelf, going to Home Depot and pick it up. Probably not.
Okay. Do we know whether implementation of these windows could be informed by policy, as with ESG or other equity considerations for historically disadvantaged communities?
Okay, I'll answer that, but probably maybe some folks at GSA maybe can help me at that as well.
And Kevin,
So,
yeah, go ahead.
right, of
Yeah.
course, like, you know, the in terms of like a policy, I think it just depends. There's a lot of like a policy and then some incentive that's, you know, definitely encourage this type of like technologies to be deployed. But in terms of like, you know, low income communities or like, you know, or I'm pretty sure that there will be some policy that encourage like, you know, this type of technology. Usually, you know, that's what we talk about, energy justice, and then like any equity that's, you know, we are paying a lot of attention of this aspect. So I'm sure that's, you know, there's a policy encourage that.
Do we have the answer? I don't know if we have the specs ready on what the lowest visible light transmittance coefficient is for this product. If not, if we don't have that at hand, it's something that we can get back to you on.
Yeah, I don't have it at hand, and then maybe this is something that work directly with the manufacturer is maybe a better idea. They have like a spec sheet, and then maybe definitely customizing this both on solar heat gain coefficient and visible transmittance they can do, but I don't have a number in my hand.
Okay, great. Has GSA done a national analysis about which and how many buildings would be a good fit for either the quad pane windows or for window inserts? And do we have a plan yet for these rolling out these products or similar products nationwide? And Kevin, this will probably be and Tyler, this will probably be questions for you.
I'll take the first whack at that and say that we have done some preliminary analysis, but we haven't, we have no plan. And of course, there's a lot of pending legislation relative to funding that would obviously have a great deal of impact on what that would look like.
Yes, thank you. Okay.
Just want to add just real quick that, you know, when we talk about the windows, that's the opportunity is where the building types that has windows, right? So I'm pretty sure that's what like we are focusing on, like mostly on the office building. That's where like, you know, the higher window wall ratio that will providing more impact. And that's also like, you know, the major improvement that any designer can put into the building envelope as well. So.
Great, thanks, Gasol. Were there any studies done on sound transmission reduction with these windows?
That's a good question. Again, like this is not part of our research study, but in general, people, when we at home, when you have like, you know, a single pane versus double pane nowadays, you seeing like the significant sound reduction. So I'm very positive that will be a significant improve on the sound reductions of this technology with, you know, 4 panes of windows compared to like, you know, a single or double panes.
Thank you. Do we know, has there been other research, other extramural research being done at this time? Is there any secondary research on these for this topic in these windows? Yeah,
I'm proud to saying that our lab, this is like the first quad pane windows. A lot of study on the triple pane window right now. You know, they call it thin triple, you know, right? The thin glass technologies on the triple. But this is like kind of, as far as I know, that's already published. This is the first one of the Quad-Pane.
Great. I don't think we can answer this question. I'll go ahead and ask it. Do we know whether there's an application in motor vehicles or airplanes? again, it's not what we do, so we'll probably, that's not really a question that we can answer. So let's see. I'm trying to pick out some other questions that were there. There was a question about the cost data, and we do have seen, we know costs across the board have increased in the last year. So is this cost data from 2022 or from earlier?
This cost is like, I would say that is around pre-COVID, pre-COVID time, like, to like early COVID time. So definitely there will be some increase with the labor costs. I would expect, because of like inflation hit everything, right? every industry. So, but again, but this is like the cost, like, about pre-COVID or early COVID time.
Great. What are the associated warranties for this window technology, and how does it compare to, if we know how it compares to a conventional double pane IGU?
Yeah, the company has like a same 10 years warranty. I think this is like a minimum 10 years warranty, but they always say like, a lifetime warranty. This type of like, company, sometimes they're providing extra and beyond, although they might saying like 10-year warranty is a standard, but there's some other material or some other thing that lifetime warranty, that's covered. So you have to look into a detail of like, the warranty information.
Great. Do we know if there are any energy rebates for choosing Quad-Pane windows or for improving the building envelope? Tyler, you might have an answer for that one.
Yeah, it's going to be utility specific. So it's going to depend on the utility programs they offer. And then oftentimes what we've seen with that type of technology would be a custom rebate. So I think my biggest recommendation, reach out to your utility rep for the building and see what they have available. Okay,
great. Let's see. I think we're just about at time. Those are a lot of great questions. Thank you. And again, this technology is really geared at new construction and major renovation. And there is another technology that the lightweight secondary windows from the same manufacturer that report is released, and we'll be hosting that webinar in March. And so after this webinar, you'll receive, if you want continuing education credit, that's available through the American Institute of Architects, and that includes that health, safety, and wellness credit for attending this webinar. So if you complete the survey that you'll be receiving later today, you can request credit. And then the date of that next webinar is March 3rd. You should all, if you will, have received an invitation. If you haven't, we'll be sending that out again. And so thank you all for attending. Thanks for all the great questions, and to the presenters, and hope to see you on March 3rd.